Good morning, guys. So today we're going to be continuing on with chapter 4, and I have a nice, short, easy lesson for you. We're going to be talking about how to convert between radicals and fractional exponents, which, don't worry, is not as tricky as it sounds. Okay, so this is lesson 4.4, radicals and fractional exponents. And so a fractional exponent is just anytime your exponent of a power is a fraction. So for example, here we've got a power, this is our base, this is our exponent, and our exponent is a fraction. Now we can convert that into two different types of radicals. One is called a power of a root, where you have your root and then the entire thing is to the power of some exponent. Or you can write it as a root of a power, where you have your root and then your power is entirely underneath the root symbol. Both of these, the power of a root and the root of a power, mean the same thing. So if you're asked to convert your fractional exponent into a radical, you can convert it into either the power of a root or the root of a power. Okay, those are both equally correct. When you're doing that conversion, you start off with your fraction, that is your exponent. The numerator, so the number on top of that fraction, is going to remain an exponent, even when it's in radical form. The denominator of your original fractional exponent is going to become the index of the root. So we're going to just walk through a couple examples of what this would look like. So in this case, I'm starting off with a root of a power. If I want to convert this into a fractional exponent, I just keep my big number. So I'm going to keep my 5, that'll be my base. And then its exponent will be a fraction. The numerator will be whatever the power was, or sorry, whatever the exponent was in the root. So the 4 is going to go on top. And then my denominator is whatever the index of the root is. So 3. That's it. That would be my answer. Okay, you might also sometimes see a root that does not appear to have any numbers other than the base. Once again, I'm going to keep that base as my big number. This time, my fractional exponent, the numerator is whatever the exponent is in my radical. And because there is no exponent visible, really it's an imaginary 1 that we could draw in there, because 3 to the power of 1 is the same as just saying 3. So that's an imaginary 1. We don't actually write it in there. But we do write it in when we're writing it as a fractional exponent. And then because this is a square root, the index of this root is also invisible, but it's an invisible 2. Square roots always have an index of 2. So that is what it should look like as a fractional exponent. I can also go the other direction, so I can start off with a fractional exponent. 27 to the power of 2/3. And I can convert it into a radical. Again, I'm going to keep my base, keep my big number. The numerator of my fractional exponent stays as an exponent. And then the denominator becomes the index of my root. Now, if the question just asks you to write this fractional exponent as a radical, then this would be your final answer. However, sometimes it might ask you to actually solve. If it asks you to actually solve, then what you're going to do is figure out what the cubed root of 27 is. So in my calculator, I'll plug in the cubed root of 27, and the answer is 3. So I've solved the root part first. I've ignored the little squared sign, and then I can square it. And then 3 squared is 9. You might also do it the other way, which is equally valid, where you do the squared part first. So if I do 27 squared, I get 729. But in this case, I haven't taken into account my cubed root yet. And so then I'll do that part second. I'll take my cubed root of 729, and I'll get 9. So both of those are equally valid ways of solving. You can either do the root portion first or the power portion first. So either do this part here first, the 27 squared first, or do the root of the cubed root of 27 first. Okay? Either way, you get the same answer. The one last thing I do just want to remind you of, and it's actually a rule that we learned in grade 9, is that if you have the root of a fraction, that is the same as doing the root of the top over the root of, oopsies, the bottom. Okay, so you can separate it like that. Okay, let me know if you have any questions. Your homework will be posted on your Google Classroom.